Welcome back. This is 9.2 Part B. We looked at regular polygons yesterday, and we're going to look at circles today. I think some of you guys have done this. This hopefully is a refresher. So I'm going to add some more polygon stuff at the end. But just in case, I thought I'd throw this in here. So a couple things. The center of a circle is right in the middle. It's just called the center of the circle. If you go to the edge, any spot right here or even here, that is called the radius. And if you go straight across, as long as you're cutting through the center, that is the diameter. So if you take the radius and you double it, that will give you the diameter. So diameter is 2 times the radius. Hopefully that is review. If you have two pieces or two radii, let's say these two, this angle is called the central angle. We'll look at this in other chapters, but I just wanted to introduce it to you. So there's a little bit of vocab for you. Circumference is if you measured all around the entire circle. And that formula is either pi times the diameter. Remember, there was a tough test question once that said, what's the ratio that pi represents? It was just circumference divided by diameter. So if you have any circle at all, if you take the circumference, measure it with a string, and the diameter, measure it with a string, if you divide those two, it's going to be 3.14. So if you want a little extra, if you're bored at home, then try that. Or you can just keep watching. So circumference is pi times diameter. Again, diameter was equal to 2r. So if you'd rather write it pi times 2r, or they write it 2 pi r, they're just rearranging, that works as well. The area of a circle, if you recall, is pi times the radius squared. Make sure order of operations, you do this first. You square the radius first. So let's try a couple of these. It says find the circumference and the area and leave your answer in terms of pi. So the circumference here, since they gave us the radius, I'm going to use this one, 2 times pi times r. The radius is 16. Oops. 2 times pi times 16, and I just get 32 pi inches. If you'd like to get a decimal, you can type that into your calculator, and you will get 100.53 inches. So either one of those will work. The area of this guy would be pi r squared. So pi times 16 squared. Again, square the 16 first because of order of operations. So you have pi times 256, or the area is 256 pi. You can leave it like that, inches squared. Or if you'd like to get a decimal, just multiply that by pi in your calculator, and you'll get 804.25 inches squared. I think we've done this a lot before. I just wanted to give you guys a little refresher. Let's try one more of those where they just give that to you. Sounds like in your homework they amp it up a little bit. They may give you the area and then ask you to work backwards and find the radius. They might give you the circumference and make you work backwards to find diameter and then keep working backwards to find the radius. So it could go kind of either way. They could give you this number to start and say, hey, can you find the radius? And you would work backwards. If you want to know how to do that, just a quick show. If they gave you this for the area, and you know area is pi r squared, you would cancel the pi's out. You would be left with r squared. You could take the square root, and you would get the radius to be 16. So either way. But this one, again, gives us the radius or diameter. This one, it gives us the diameter. So I'm going to use pi times d, which the circumference would be pi times 22, or just 22 pi meters. If you'd like a decimal, you can do 22 times pi, which is 69.12 meters. To find the area, we are going to need to take that diameter and cut it in half, because the diameter is 2 times the radius. So if the diameter is 22, that would mean that our radius is 11. So then, wrong color. Then I can do area equals pi r squared. The area will equal pi times 11 squared. The 11 has to be squared first. So I'll have the area is 1 pi times 121, or 121 pi meters squared. And again, if you would like to do a decimal, you can type that in your calculator, and it will give you 380.13 meters squared. And again, they could ask you to go backwards as well, giving you the area or circumference and working backwards to get the radius or diameter. So that's pretty much it on circles. I thought that was pretty short, so I'm going to add in some more polygons and maybe a little word problem and some ACT stuff. I know you've missed it. I know you've missed the word problems in the ACT work. So here, let's go back to regular polygons. So remember, we break it into triangles, find the apothem, find the angles, and go from there. I wanted you guys to see on this one a little shortcut. This does not work for all shapes, but it does in this case. I could, again, find these, do 360 divided by 4. I'd get 90. I'd cut this in half. I'd get 45. This is 8. I'd have to do, so this is also 8. I would have to do some Pythagorean theorem stuff. Both of these are x because it's a 45, 45, 90 triangle, 180 minus 90 minus 45. And it would work. It would just get to be a lot. I wanted to show you one shortcut, which some of these really are a lot. I just wanted to show you a shortcut on this one though. Since this is a regular polygon, that means it's a square. All the sides are the same, and it's 4-sided, so this is a square. A square is a type of rhombus, and if you remember, the area for a rhombus was 1/2 times diagonal 1 times diagonal 2. If it's a square, the diagonals are the same, 8 and 8, that one's 16, and 8 and 8, that one's 16. So if you want a quick shortcut on a square, you can just do it like this. It doesn't work for all polygons, but I thought I would show you that shortcut, and the area is 128 millimeters squared. Much quicker than starting all of that. We will have to do that most of the time, but when you see a square, make it easier on yourself. So I just want to show you that shortcut. With our extra time today, I'm also going to add in ACT. If this is overwhelming you, you can just change it to a decimal and do it just like you would the other problems. But for those who want some ACT practice, I'm going to keep it with the square root. So let's draw this. It's leaning to the side. That's just more annoying than anything else, but it doesn't change the area if it's sideways or not. So because it's annoying me, boom, there's 2 ways to solve that. Just made it straight. Yep, it doesn't want me to. Here we go, and there. So this apothem is, I'm going to draw my triangles, 6 triangles, so hexagon, 16, let's make this bigger just for ease, 16 square root of 3. And that is a right angle. So 6 sides, I'm going to do 360 divided by 6, which will give me 60. for each of these, meaning this one, 60 cut in half, has to be 30, if you remember that from yesterday. If we do 180 minus 90 minus 30, that will give us 60 degrees. And so if we're looking at this triangle, this right triangle, this right here is 60 degrees. We know the apothem, but we do need to find this base. And okay, we are working with ACT stuff only. So I could do trig like we normally do. However, that trig is going to give me decimals, which they won't have that on the ACT. So what I'm going to do instead is remember our special right triangles. So this one works because it's a 30, 60, 90. Other ones would have to use maybe Pythagorean theorem or some trig and leaving that in your calculator all until the very end. But if you remember, the shorter side times the square root of 3 equals the longer side in this case. Oops, not LS, little tiny LS. The longer side is 16 square root of 3. So what should the shorter side be? Boom, cancel those, and the shorter side is just 16. So this x is 16. The whole entire thing would be double that, or 32 for this whole length right there. So now I have the base and the apothem. I can find the area of one triangle, which is 1/2 times base times height. The base is that whole thing, or 32, and then the height is the apothem. So again, the area of that one triangle, ACT mode, is the 32 times 1/2 is 16, and then I'm going to do 16 times 16 in my calculator to get 256 square roots of 3. So that's one triangle. If I wanted the entire hexagon, I'm just going to take this 256 square root of 3 and multiply it by 6. So the 256 times 6 is 1536 square roots of 3. And that would be the answer that they have on the ACT. Our unit here was inches squared. Again, if you want the decimal answer, if you want to just try it on your own that way, you should get, side note, sorry about that. With decimals, it would be 2660.4 inches squared is what I got. But just wanted to show you kind of the ACT method. So I'm going to shrink this down. So we saw a shortcut, we saw the ACT method. Let's do one little extra problem since circles went so quick. Let's do a word problem. I don't know what the weather is going to be like, but hopefully nice. I miss playing soccer with my church league. We were really bad, though. We lost every single game, so maybe I need to try a different sport. It was fun, though, so that was good. But they're saying a soccer ball's outer cover is made by stitching together 12 regular pentagons. So if you see the black ones, let's see if I can get this pentagon. The black ones are the pentagons. There's 12 of those. Let's change that to black. And then the white ones, there's 20 regular hexagons. I'm going to use gray just so it shows up for the white. So we have the hexagons, and there are 20 of those. They want to know how much material are they using for the soccer ball. The only thing they tell us is that they have a side length of 3 centimeters. So let's get started. Make these a little bit bigger. And the only thing they told us was that this is 3 centimeters. So we can find the area of a pentagon. This is just practice from yesterday. We'll go to the center, and we're going to need to find the angles and the apothem, just like we usually do. 360 divided by 5 for the angle, and that should give me 72. So that's 72. If I cut that in half, I'll get 36 right here. So 72 cut in half is 36. This is a right angle, and I can do 180 minus 90 minus 36. And that will give me this to be 54. So if the whole base is 3 centimeters, that would be 1.5. And let's try to find the area, the apothem right here. So we could use 36 or 54. I'm going to go ahead and use the 54. If I'm trying to find this, I have opposite and adjacent. So tangent of 54 equals opposite over adjacent. Multiply both sides by 1.5. And I'm going to do that all in my calculator at once. Tan 54, that's 2.06 is the apothem. So I can then find the area of this black triangle right here. And that would be 1/2 times base times height. The base is the whole 3 centimeters, and the height is 2.06 right here. So the area of that one triangle is, type that all in my calculator, and I'll get 3.10. And that unit would be centimeters squared. Now, that's just one triangle. A pentagon has 6. So, I'm sorry, 5. A pentagon has 5. So the area of the pentagon is that 3.10 times 5. And I got 15.48 in my calculator. And 15.48 centimeters squared. So that is just one of our many, well, 12 to be exact. So there's 12 regular pentagons. So I'm going to move this over. I'll write here all 12 pentagons will equal that 15.48 times 12. So all 12, these are black on the soccer ball, pentagons are equal to 185.81 centimeters squared. So that is just the black part of the soccer ball. So we need to do the hexagons next, which I've done in gray so that we can see it. So if we're going to do a hexagon, let's move this. And we're going to start it just like we always do. So this is good practice for these types of problems. So 6 triangles, we'll break it up into. And that's 360 divided by 6, which gives you 60. So they're each 60 degrees. This, if I cut that in half, will be 30. So 180 minus 30 minus 90 gives me 60 degrees for this guy. On this one, you can use your choice. You can use the rules for 30, 60, 90 triangles, or you can just use trig. I'm going to use trig this time since we used the rules last time. So if the whole bottom is 3, then it's 1.5 for this little guy right here, which makes up the bottom of that half triangle. So if I want to know the apothem here, or the height of that little triangle, I can use 30 or 60. Let's use 30 this time. So I'll say, it looks like I have opposite is 1.5 and adjacent is x. So I have tangent. I'm going to multiply both sides by x. And I have x times tangent 30 equals 1.5. I could type tan 30 into my calculator. I'm just going to leave it written like this so I don't have to write down all those decimals. And once I type that in my calculator, I'll have 1.5 divided by tangent 30, and that gives me 2.60. And that would again be centimeters, just centimeters because it's the height. So I can find the area of one of these triangles. So this whole thing by doing 1/2 times the base times the height. So area of one triangle is 1/2 times base times height, which our base is 3, the whole entire base, and our height is 2.60. I'm going to type that in my calculator, and I get 3.90. So the area of that triangle is 3.90. And then that is just one of the 6 that are made up in the hexagon. So the area of the hexagon is 3.90 times 6, and I got 23.38. So the area of the hexagon is 23.38, and the unit was centimeters squared. So again, this is a lot, and we still just found one of those white hexagons. But if I want to do all of them, this one said it had 20 hexagons. So all hexagons would be 20 times that 23.38. And if my numbers are a little bit off, I'm just using my calculator. It has like 7 decimals or something. That's what I'm actually using. And I got all hexagons, so all 20 white hexagons would equal 467.65, and again, centimeters squared. We're almost done. So last but not least, if we want to find the area, basically the surface area of that entire soccer ball, we are going to take our black pentagons, add them to our white hexagons, and let's pick a good color, fun purple. There we go. Add those two together, and we will get 653.47 centimeters squared. Let's make that box pretty if we're going to do all that work. There we go. Beautiful. Okay, so I just wanted you guys to, since we did a little bit of a review with circles, I thought I'd add in a little bit of a shortcut here, show you some ACT work here, and then throw a pretty intense word problem at you guys. Tonight's homework is mostly the circle stuff. You will have to work backwards a little bit, but I just wanted to show you those extras as well. Hope you guys have a great day. See you later, hopefully soon. Bye.